she said. My name's Frank Vitz. I'm the creative director for CryEngine at Crytek in Frankfurt, and it's really a pretty cool job. Whoops, I have to get I have notes here, so I'm getting... It's a fun job because we have a reputation for being one of the most powerful real-time engines in the world, and over the past couple of years we've been working to apply the power of CryEngine to the realm of virtual reality. It's a lot of fun because the end result is that people tend to be amazed by what we're doing. If you're starting to develop in VR now, you know how it can be a daunting process, but don't get discouraged. We're getting to invent a new medium here. The cool thing is that today I'm going to talk to you. Dominic did a really good job of talking about all the technology. This is the stuff I usually talk about: rendering, frame rate, latency, all that kind of stuff. But today, I don't have very much time, so I'm going to show you what you can do with an engine like CryEngine when it has the power of all these devices and all the technology that NVIDIA has to play with. So we're in a good position to do this at Crytek because we build the engine for our user base, our community, and we also use it in-house ourselves to build AAA titles like The Climb, which is on Oculus now, Robinson: The Journey coming to PlayStation VR, and VRSCORE I'm going to show you a little later. No matter what business and what aspect of business of virtual reality and AR you get into, you're going to find that there's an engine like CryEngine, except CryEngine is a real engine, so you know it's going to be there somewhere in the heart of what you're doing. So today's agenda. We're going to talk a little bit about what does it take to make... I've only got a little bit of time, so we're going to skip over a lot of stuff here. But basically, realism in VR and the rendering stack, some insights into level design, characters, and audio, a peek at the challenges of how you do creative design of a narrative in VR, and then a couple of closing thoughts. So, what does it take to create immersive content in VR? The Holy Grail is that sense of immersion. You know, the promise of virtual reality is to provide an experience of a simulated real world, or a simulated world that feels real. It seems obvious, right? But before we can do this, it's a challenge. We have to, before we can design the creative experience, we have to take our players across that threshold, get them to suspend their disbelief and become immersed in the world that we've created for them. In the good old days, it was a flat screen up there, right? And there was a sense always that you were looking through a window. Today, that separation is gone, or at least that's what we're trying to make happen. And that involves fooling our senses even more so than what we've done so far. This is a frame from The Climb for Oculus Rift. We render this 90 frames per second per each eye. That's 180 frames per second at this kind of resolution. Keep in mind that film and video, film's 24 frames per second, video is 30 or 60, so we're like going 4 to 5 times as fast. So this is pretty amazing, the ability to render a believable world in this kind of detail at those kinds of frame rates is the fundamental challenge, and it's what you need to do to be able to create immersive content, I believe. So let's take a look at what it looks like. You have to see your headset, of course. This is just a simulation of the feel, but when you're there, we don't give you any vertigo except the actual vertigo you would feel if you found yourself hanging on the side of a cliff somewhere. So, there's a lot of things going on behind the scene here to make this possible. I'm going to touch briefly on 4 components of it that are powered by the engines like the hardware of AMD and NVIDIA. Basically, physically based rendering, image-based lighting, volumetric effects, and advanced particle effects. So these are the things that, taken together, allow us to create that kind of photorealism. The first one is physically based rendering. This simulates the interaction between light and objects in the real world using real physics. This isn't the way we used to do it, but this leads to much more natural and believable results, and everything looks much more plausible. We refined PBR during our work on the game Rise, and now that we've optimized it with a rewrite of our renderer, we can do this kind of thing in real time in VR. So, another big advantage of physically based rendering is consistency factor. When an object or the character's materials are set up properly, they will work regardless of the lighting scenario that they were originally designed for, just like objects in the real world. This can be a huge win if you want to use your assets in other projects. So we can make props and characters that are truly portable. If you liked Crisis and you liked Rise, Son of Rome, well, what do you think of the idea of nanosuits fighting against barbarians? Well, whether it's a good idea or not, PBR can make it possible. So, another component is image-based lighting. This works together with physically based rendering. What it does is it's a rendering technique whereby we take all the complex information about the way the light is in a room and we capture it into something called an environment map or a light probe. Here you can see it. They look like mirror balls. Of course, in the game, you don't actually see them, but what they do is they encode very compactly all of the information about the complex light. And we can pre-compute that, use it, and your images look photorealistic, but you can still do it at 90 frames per second. We also take into account what happens when the light from those objects around a scene are prevented from reaching the objects. That's how we get these kinds of great dark shadows. Crytek has always been known for being able to make really great forests, which is appropriate for a company that's located in Germany, I think. In the real world, there's atmosphere everywhere. What I mean is the air feels transparent, but it's not, and fog can give you a sense of depth. And the way we do this, you can fake fog by putting a little bit of a tint or a little bit of a gradient in your scene, but in VR that does not work. So we have now volumetric fog. I won't go into the technical details, but it means that the atmosphere is actually 3D and it surrounds the character. When you move your head, it fills the space, and those light beams feel like they're coming right past you. Dimensions of light and shadow. We also have taken that a little bit further now with our volumetric clouds. We can take the transparency of the clouds and create cloudscapes that you can fly through. In video games, particles are synonymous with visual effects, and they're the most efficient way to create a lot of different things like sparks, water, clouds, explosions. We have a new particle effect system in CryEngine designed specifically to run on the GPU so you can do this stuff in VR. And they're not just for explosions and sparks. You can also do things like this weird sea creature here with its tendrils glowing, for example. Those are made with what we call ribbon particles. So that's how we render things in CryEngine. Let's take a look at how we do a little bit of level design. The Climb team took the dyno demo that we did about 1.5 years ago where we did motion control based on the hand controller. The system worked so well that we used it as the input system for the climb, and people can use their hands to lock onto and climb through the world. Now we knew that the touch controller from Oculus was coming, but we needed to make a game that would work with both hand controller and the new touch controllers, because the last thing you want to do is require a new buyer to purchase additional hardware when they have already shelled out hundreds for their head-mounted display. But once we're able to climb around in the world, our designers, this opened up a new playground for them. They could navigate through the world using their hands, to pull themselves up. And they experimented directly in VR, creating different types of handholds and modeling different shapes of terrain. This shows what it looks like behind the scenes when you're climbing in the climb. There are handholds, collision volumes to prevent you from pushing through the rock face, trigger points for debris, all designed to surround you. It's really wonderful when you feel like you're there on the rock surface and able to go wherever you want. Now, a great VR experience is not just about rendering and gameplay. Audio is arguably really important. All the inputs to your senses have to be in high fidelity and in sync for you to believe that you're really there. And in VR, this is even more important. If the sound isn't quite right, it can break the immersion. So we have implemented in CryEngine something called HRTF, which means head-related transfer functions. It's a fancy way of saying that we actually can detect where the sound is coming from, and if it's behind your head and blocked by your ears, it will change the nature of the sound. This gives the player the feeling that the sound is right there in the world with them. Just another way of reinforcing the sense of immersion. So that's a quick sampling of some of the technical challenges. Let's look at a creative challenge here. I'm going to base it on something called the VRSCORE benchmark, which we made in conjunction with Basemark. The idea here is this is a benchmark, so it has to run repeatedly, so it's a linear VR experience. But we thought the best way to make it fun, rather than it just being a technical test, would be to make it into a story. My art director, Erasmus Brosdow, already had a concept for this wonderful place with flying aircraft carriers and little brave maintenance droids fighting against the evil Crown Patrol. It was a perfect place. So we decided to use this to demonstrate the power of CryEngine, but also to explore narrative design. So we went through the normal process, doing a concept, a treatment, and then storyboards. But we realized that the storyboards that we have did not fit the challenges of VR, so we invented a new one called a VR storyboard. Here you can see on the right the frame that's intended to show where your player is looking. On the left is the radar view, because the main problem that we have in virtual reality is, unlike traditional cinema, the director doesn't have control of where the audience is going to look. So we decided to explore that space. Here you can see a little pie shape that shows where we think the audience should be looking, and we designed a scene where a jet comes flying in and is supposed to attract your attention. And we've created this storyboard as an exercise in our own minds to figure out how we wanted to design the scene, but also to let our level designers build something to test it in. So we built this, tested it, put it on the head-mounted display, and got unsuspecting people out of the halls to try it out and see whether it worked. We gradually refined it and eventually came to the point where we had something that worked pretty well.
Ah, sorry. And you're still stuck. Crowd Patrol, we're done here.
How much time do I have? I've been talking really fast. You know, usually I'm used to yakking for, now I really do have to go fast. I'm used to yakking for like 45 minutes about this stuff, so I wanted to show you all this stuff. Anyway, this is like one example of a technique, how to tell a story in VR, and it's really an interesting challenge, and there were a lot of other ones. If you get a chance, when Sky Harbor and VRSCORE come out, publicly released this month, you'll be able to download it and play it. Of course, just like everything else I've been showing you, when you see it in VR, it's a completely different situation. But the main thing is we created stuff that surrounded the user to the point where they want to come back and see it again and again. And this is our trailer for that piece.
Looks like you droids can use some muscle.
Well, coming fall 216. We had to polish it a little bit, you know.
Achieved with CryEngine.
So, the last thing, what we've been doing is we've been taking the power of CryEngine, integrating it into VR, and we've made a lot of progress. We're sharing this with our users, and now we're working on mobile VR. We have that running, and interest in the market is huge. I think the payoff for early adopters who are ready when it hits is going to be even bigger. And VR is really cool, but of course everyone knows that if we can seamlessly bring this kind of fidelity into augmented reality, this kind of experience, adding rich layers of media on top of the real world, that's what's really going to take off. So yesterday in Frankfurt, I created a little video with my HoloLens that shows kind of where we're headed.
Today we're leveraging the power of CryEngine across a wide range of different platforms, including the PC, the Xbox, the PlayStation 4. We've brought CryEngine into virtual reality, supporting a variety of different headsets. Here in my office in Frankfurt, I've got CryEngine open on my desktop PC.
The frame rate's better than that,
and we've loaded up
actually.
the wonderful world of Sky Harbor that we've been looking at. Place of flying aircraft and clouds and crazy rock formations. And it's the home of the brave little maintenance droid number 20 Run that we met earlier. Here I've got number 21 open in Maya on my second monitor. Now, with virtual reality, we can bring these characters to life on the Oculus Rift, but today we're not limited just to virtual reality because I'm wearing my HoloLens, which allows me to extend my desktop into the virtual world. Here we've got some virtual windows hanging in the air around me on my desk, including CryEngine.com. I have a 3D viewer here where I can even load up a FBX model of little number 21 and bring him to life right here on my desktop. This is the power of the HoloLens, taking virtual reality and bringing it into the real world. It's almost as if number 21 was right here on my desk with me. That's right, virtual reality, moving into augmented reality and beyond. This is the future, and this is where Crytek is headed. Okay, Cortana, stop recording.
So that was just purely unrehearsed, and actually the frame rate's a lot better than that, so it was pretty mind-blowing. The number of installed Rifts is growing, and analysts are predicting huge numbers in our business. I posted a similar video to that on my personal Facebook page, and in 3 days it went up to like 20,000 hits. And I know I don't have that many friends, so I think it's safe to say that we have captured the public's imagination. Now all we have to do is deliver on the expectations. For that, you need a really good, solid engine that takes all the technology we've been talking about and brings it together, places you in the action, sound, sight, and motion, and provides the tools for you to make good creative decisions. Use these tools to tell your story, figure out what your market is, whether it's going to be an interactive game, a linear VR experience, augmented reality. The future is wide open. You know, it's basically, I like to say, that this is like a new wave that's arriving, and it feels like it's going to be a big one. With the right tools, you will have the freedom to ride the wave regardless of what business you are in. So, see you all in the metaverse.
Thank you so much. We can open this to the audience, and you see that is a packed room. So do we have questions?
Apologies for talking so fast, but
No, I think everybody got it. And you see more and more people came in, so they told them, go to the other room, go to the other room.
I wasn't going, no, wait, I have more to, come back. I didn't have to do that.
So if you don't have questions, oh, there's one. Can I have the microphone in the second row, please? Otherwise, I have 2 questions also.
Great.
Hey. According to PBR and IBL, what do you think, how fast will we get animated and dynamic IBLs, like light probes for dynamic lighting?
How fast?
How fast I will be there?
Oh, well, we currently have something called sparse voxel octree global illumination, which is really cool.
All right.
SVOGI, it uses light probes and it dynamically computes them on the fly. So we have dynamic global illumination. It runs in about 2 to 3 milliseconds per frame, which unfortunately isn't fast enough for VR, but we can do that maybe even just slowly in the background if we need dynamic. Is that what you mean?
Yeah, kind of.
Yeah,
So
and
you
because
basically
the global
pre-render-
illumination is so beautiful. It's how the separation between stylization and photorealism. CryEngine has always been about being able to create photorealism. Arguably, it's not necessity. If you want to have stylization, and we see a lot of VR now today that is stylized. I think partly because of performance limitations, but also because you want to tell a different story. But if you have the ability to use it, if you want to create something like the holodeck or the matrix, then you need photorealism. And I think that's kind of where you're headed, maybe.
All right, so you basically just pre-render, create all the different states of the light probes and store it in the NOC tree?
You can do that. And the light probes, when they're static, they're quite small, and so you can just distribute them where needed in a level to create that. And then you can have dynamic lights. Everything else in the lighting in CryEngine is dynamic.
All right, thank you.
Okay, one last question from me. You talked about volumetric clouds.
Yeah.
Volumetric everything. In my office at Fraunhofer, we talk about volumetric video. So there are a couple of companies that work in this field, which is 8i, Incorporal, Google, Microsoft, Fraunhofer.
Yeah.
And you're saying it's all about photorealistic approach. Do you consider to put volumetric video, so we're talking about 3D human body reconstructions into your world?
Yes, again, CryEngine provides a framework for that. We have a spin-off now in something called Film Engine, which is designed to composite live action with synthetic footage, but not just in the conventional sense of a 360 flat video, but in a volumetric stage. And
so
I think that's really great.
That's the mix of the real native shoot and CGI, right?
Yeah. It's like the idea of composite, getting a light probe that tells you the lighting of the world and using that to create synthetic characters that you put in a flat movie.
Yeah.
But if you do it three-dimensionally, you need to be able to move your head around. And that's where actually the same technology that we use for light probes will allow us to capture a light field, which is essentially a synthetic 3D volumetric representation of the world.
Cool. We should talk later on because I have a speech on the other side, and I will get to that topic. But one more question. You said 108 frames. Is that
180.
correct? 180.
Yeah.
What is the human eye perception like? How much can we go? And
well,
when is not
it's
hyper
arguable.
realistic?
Some people can see faster than others. In North America, we have 60 cycle per second electricity, and lights blink at that rate, and I can see it. I can actually see them flickering, or if you move your hand in front of it, you can see it flickering. The problem it's a similar problem in virtual reality, except your whole world is flickering. So we think that 120 frames per second is probably the best spot, but 90 frames per second, most people can't see the flicker.
Well, I can tell you, and then the next speaker is from GoPro, so camera approaches, that the cameras at the moment, well, they do 60 and 120 frames, but how can we show that? There are no TVs that have 120 frames at the moment.
No, but give those guys an excuse for selling us a new TV.
Yeah, actually, I'm pretty sure that will come up next, but that's another topic. And so I want to close with this, and thank you so much for coming. And I hope you stay here for the next 2 days.
Yes.
Perfect. Okay, thank you so much.
You're welcome. Thank you.
Thank you.